Hello everyone, welcome back to the second episode of the HP 3325A synthesizer function generator restoration. I received some spares. I start to see how I can fix this problem that I really don't like it, since prevent me to remove the bird from the instrument. So this is what I have received. There are spare capacitors, the 2200 and 8200, like that, and the triac for the replacement of the broken one, and last but not the least, the Molex connectors that should allow me to fix this problem. So I will go ahead first on this replacement to remove the bird and go ahead from there. All the wires has been removed and the relevant terminals crimped on. So now I can have my bird in my hand and start the cleaning of this connector, as well as the capacitor replacements, cleaning, and so forth. I will make some room here because it's a real mess here. Good progress here. The connector is cleaned. The capacitor has been replaced. I've checked all the semiconductors and they seems fine. I have replaced the triac. So at this point we can proceed to the installation of the board back in the instrument. But before that, I want to check some basic condition of the power rails to avoid to let this bird be powered up with some shorts on its output. So let's go ahead with that task. Okay, I've got the front panel reinstalled. I managed to find all the missing screws, including those on the PCB. Perfectly fine. Just a very quick clean on the upper board. I have installed the Molex connector. So what I want to do now is to try to see if I have some short in this 5-volt rail, which is separated from the main PCB, main power supply. And the way that I will do it is to apply DC voltage right here at the AC input. That should allow me to check both bridge rectifier, capacitor, and so forth in the rail. And doing that with a limited current external power supply should also allow me to reform the capacitors and give the supply slowly. So let's go ahead with that task. Okay, I'm feeding voltages, DC voltages, with the external power supply. I'm currently at 8.3 volts and I'm having 5 volts on the ICs here. So well, clearly part of the supply here is fed by the main power supply. So this rail is working, so I can proceed to the installation of the power supply, and it's currently draining 25.25 amps, so 250 milliamps. So looks fine. Here we have the high voltage option board right here, and here we have two outputs, minus and plus voltages, plus 30 and minus 26. So what I want to check is the DC resistance relevant ground, and be sure that we don't have any short circuit. So this is the minus 26, 2 megs, plus 30, yeah, it's moving around because capacitor, but seems fine to me. So I can now be safe enough to connect the power supply board and try to power it up, the instrument. Okay, this is the real moment of truth, and I've already plugged it in to the variac, so I will raise up the voltage, and I'm currently at 20 volts. Power button is already pressed, so let's see what it does. I am not expecting so very much. I heard a little click. Okay, the fan is spinning. I'm at 150 volts, but nothing is happening. I'm at 180 volts. And by the way, I was wrongly thought that the instrument were setting 220 volts, but actually was set to 220 volts. So I suspect that something is wrong here, and indeed we don't have any live sign here. So let's try to give a reset like that, and we don't have any live sign. So let's check our voltages. We should have here plus 15, 3 volts, plus 5, nothing, minus 15, it's bouncing. So it seems that power rails are down. So let's see the primary voltages. This is the plus 20, should be plus 20, and it's limited in voltages, so it's fine. This is plus 5, and it's fine, and this is minus 20, which is minus 15. So primary voltages are fine, but the regulator is not working. So let me move the camera, and let's see the strategy how to troubleshoot this. Okay, so here we have our primary voltages, plus and minus, which are present, and we don't have the output. And this also is the primary voltage for plus 5, which for sure it's working since the power relay is clicking and the fan is spinning because of that. So that is driven by the soft start push button in the front panel. So the service manual gives very short indication and suggests to remove P5, which is the output plug, exactly this. The removal of that will prevent the power supply to switch on through the front panel power switch. So it suggests to make a short bridge between pin 10 and to ground. At this point, if I jump this, I should have my power supply on, and let's see if it's true. And indeed we have some voltage here, I have voltage here, and voltage there, but completely out of spec. So I suspect that there is something wrong over there. So let me try to go directly to the line and see if we can have some different behavior. Okay, minus voltage seems almost fine. Plus voltage is wrong completely, and plus 5 the same. So for sure we have some problem there. Well, I was actually completely mistaken. The entire board here, and including the metal sheet here, it's separated to this ground, and there are plastic studs to do that. So if I touch here, doesn't start. So the reading using this ground as a reference, it's wrong. Indeed, if I touch here, the fan is spinning, and now it's really powered on. And indeed, if I also go to measure the voltages, I'm having exactly plus 15, minus 15, and plus 5 is 4.7. It's bouncing around, so plus 5 seems to be a bit weird. But all in all, it's working. So I think we should refit this plug and check the voltages referencing to this ground. Well, let's try to refer to this ground and let's measure the voltages. I have clearly plugged back the rails, the output rail, and indeed the voltages went down. So at this point, since all the rails are distributed by these flat ribbon cable, there are 3 of those that make the power distribution. So I will remove one by one, and I should find where the problem lies. We still have low voltages, so let's remove this. It might also be that the power supply is faulty and it's able to run only without any loads. Indeed, 5 volts was bouncing around. By the way, it's better to see if it's true or not. We clearly have 0 volt now. Yeah, without negative. Still low voltages. Let's remove the last one. Okay, look at that. Life signs. So it seems that we have a short circuit down below there. But at least, yeah, that is very promising. Let me check again. Yes, that is really, really promising. So I should have a short circuit down from there. So I will fit back the other 2 and see if we have also some other short circuit. So there is this aspect that there have been an over voltage in the circuit. So yeah, very nice. Now it's keeping this condition, and the front panel it's reacting. So yeah, that is really promising. Just a matter to find where the short circuit is. I have connected back the ribbon cable that prevent the power supply to power on, and indeed it still is not powering on, and it's exactly this side. So we should see now that is, yeah, and indeed it's powering up. So for sure we have a problem here, and luckily we have a few test points about voltages. So with the meter I can check the negative 15, positive 15 for shorts, but I don't see any. Then +5 either. So I need to study a bit the schematic to understand why this circuit is preventing to the power supply to coming up. Checking the rails here, I don't have any short circuit. But if I plug this, the instrument will not power on. So I'm not entirely sure that we have a problem. It might be that this bird requires a bit of more power, and the power supply is not able to give enough juice. However, it seems like a dynamic fail, that it's only generated when the bird is powered up. So one thing that I want to do is to remove one by one those coils and see if I can trace to which rail it's which rail is preventing the instrument to power it on. So let me check onto the bird layout which is which of those coils, and then try again. As a first try, I have lifted L76, which is right this, and this has cut it out the +5. So let me plug this and test again. Nope, that's not our culprit. Second try is L27, which is cutting out the +15 volt rail, which is right this one. Instrument still not powering on. So let's go to L26, which is right the next one here. L26 lifted up, instrument still dead. So clearly, as expected, I have to say, the isolation of those power rails does not fix the problem. So we might have a different kind of short circuit. Let me try this, which is an additional +15 voltage that is coming down directly from the power supply, but doesn't make any difference. So must be check it what we have as a relation between this and the rest of the board that can cause some short circuit. I think I found something. If I measure relevant to ground this coil, actually is a choke, I have a short. So for sure, this is a problem. And this is or either L77 or L76. I need to check on the practical schematic. By the way, that I'm sure is the cause of the problem in the instrument. And yes, is L77, which is minus 15 rail. So it seems that we have two separate rails, about 15 plus and minus 15. So yeah, let me reassemble those I lifted before and lifted up. I'm having something very weird. I have lifted the voltage plus 15 rail choke, and my short still is in the choke, but not in the PCB. And I am assuming that this is connected directly to this. So I wonder if I remove this, my short go away. It's going away. That is, and yes, so we might have some connection problem. Well, clearly I didn't check the schematic correctly and deep enough. The power relay rail that is faulty, it's minus 15, and lifting the coil, the choke here, my short circuit remain onto the choke, and removing the plug will go away since there is a jumper on the other bird that is brought by the ribbon cable itself, which is right this in the corner, you can see it. But as we can see, we have a second rail. So I suspect, and I'm quite sure that the problem is here. So we should have this jump. I will try to find it. By the way, I will check the capacitor's position and see if I can trace down where this voltage is going on. Well, to troubleshoot this short circuit requires the bird removal, so I will remove from the instrument and check on the bench. Well, the first thing that I have noted are this kind of capacitor, which I believe are tantalum capacitors, and just poking around and measuring the closest, bang, short. But also this one, it's 16 ohms, which is a bit low. The other seems in an acceptable range of measurements. So I will try to lift this and see if it is the capacitor itself or perhaps some of those power transistors. So let's try that. Sorry for the glare. I have lifted up the capacitor. Let's measure it. Yeah, completely shorted. And it seems to be 15 microfarad. So I will also lift this and check also that and see if we can have further damages. The second capacitor, it's fine, and it seems that also the 16 ohm resistance went away, probably because I have removed this. So it might be that just the replacement of this cap will fix all our problems. And lo and behold, this is C219, which is exactly this capacitor, which is right at the input of the rail. So that is really encouraging that we might have found all the problems. The capacitor is replaced. Apologize, I've noted just now that sometimes is out of frame the meter or the PCB, so I will take more care about that. So this is the measurements across the capacitor. We are good now, so I can reassemble this capacitor in its place and try the instrument again. The PCB is back in the instrument, so it's now time to make the test. And nope, yeah, it seems that we still have some problem. That is really weird. Let me check for some other shorts. Well, I'm actually having a similar problem than before. Look at that. If I measure this time on the plus 15 volts rail, I'm having very low ohm reading, 23 ohms. And if I remove the ribbon cable, that goes away. So I think there is a similar problem to be checked with the schematic. Well, before to make things difficult, I just went across this capacitor, dead short. Look at that, you are out of frame, you can see. Dead short. So perhaps when the instrument powered up, this capacitor went in short. So let me try to remove it, lift one terminal and try to see if it's broken. To lift up the capacitor, I had to remove the resistor first. Dead short, another broken capacitor. Hopefully that will fix. This is another 15 microfarad 20 volts tantalum capacitor. So let's replace it. Okay, the capacitor is replaced. The resistor is soldered back in its place. So let's see what it does. Okay, so finally we have some live sign with everything connected. Actually not. Let's see what it does. Finally, with all the connectors in place, we are now having a stable reading. And okay, so the function switch, it's reacting. So at this point, we should have a working instrument, at least to some extent. So let me flip it over and see more functions. Okay, I have just flipped it over without any power down. I've just noted that there is a self-test. Let's try it. Okay, it's lighting up. Pass 1, pass 2, and pass 3. Yeah, the instrument seems working fine. Let's do it again. Also LEDs. Okay, so at least to this point, the instrument is working. I have connected the output to the scope, and I'm having an output that seems fine, at least in shape. Let me add frequency. Yeah, it's 1 kilohertz as the instrument is. Let me rise to 50 kilohertz. Yeah, let me switch to square wave. It's perfectly fine. Amplitude, it's at 200 millivolt on this in the instrument. The amplitude, and frequency is 50 kilohertz. Well, it seems fine. And let's check also triangle and ramp. Okay. Let me change a bit here. Okay, that seems working fine. So I think it's a good result, and well, we have a working instrument, at least to this extent. So in the next video we'll check more in-depth performances, and I will continue the restoration of the outer case and covers and things like that, but we are having a working instrument. Clearly, we don't know how long is that this instrument is not working, and how long is that is not keep it powered up. So I will need to make a burn-in test of at least few hours and see if it's reliable. And after that, we can consider the instrument repaired. But at least it's alive. So I think that's it for this video, and thank you very much for watching.